Hi guys, welcome to this page of the notes, and again what we're doing is we're looking at multiplying and dividing functions, which is just like multiplying and dividing polynomials, except now we're just calling those polynomials functions. So let's go ahead and jump right into another example problem. Again, remember, if you don't like this notation, that's okay. You can simply write it the other way if you prefer, f of x times g of x. They mean the exact same thing, and we're going to multiply the function f of x by the function g of x. And that's just the distributive property. So here we go. I'm going to have an x squared minus 7x plus 2, right? Which is my f of x, multiplied by my g of x, which is x plus 4. Distributive property to multiply all this stuff together. X squared times x is going to be an x cubed. X squared times 4 is going to be plus 4x squared. Minus 7x times x is going to be a minus 7x squared. Minus 7x times 4 is going to be a minus 28x. 2 times x is going to be plus 2x. And 2 times 4 is going to be 8. Combine like terms, cross them off as you use them so that you don't use them twice. X cubed is my only cubed term. 4x squared minus 7x squared leaves me with a negative 3x squared. Cross them off after I use them. I have a minus 28x and a plus 2x, which is going to leave with negative 26x. Cross them off as you use them, and then plus 8. There you go. That is your product function, what you get by multiplying f of x times g of x. Let's go ahead and do the division. Well, again, if you want to, you can certainly rewrite it as f of x divided by g of x if you didn't really care for that notation, that way of writing it. But again, you should know it just simply means x squared minus 7x plus 2, which is my f of x, right? That's my f of x, divided by g of x, which is x plus 4. Ooh, and good news on this one, we can do synthetic division. My variables to the first power, my leading coefficient is a 1, so let's go ahead and do synthetic division on this one. Hopefully it'll be a whole lot faster for us. Again, first thing I need to do, even before doing synthetic division, just like with algebraic long division, I need to make sure that I don't need any placeholders, all right? I gotta have all of my powers, starting with my highest power, all of the powers in descending order. 2, 1, 0, everybody's there. We're good to go. Set the divisor equal to 0 and solve. So, x plus 4 equals 0, which means x is equal to a negative 4. So I'm going to do my synthetic division with a negative 4. It goes inside of the box. Since I don't need any placeholders, I just pull out my coefficients. So, 1, negative 7, and a positive 2. Set up a bar to divide, or to separate, not divide, to separate my work from my final answer, my quotient. Bring down that first coefficient, that first constant, and then we multiply and add until we run out of numbers. Negative 4 times 1, minus 4. That's going to be a negative 11. Negative 4 times a negative 11 is going to be a positive 44. Which should get me 46. Okay, remember, the way this works, that last number is always going to be your remainder. This guy at the end is always going to be your remainder. Let me make sure I did that right. It should be a positive 1, negative 7, positive 2. Bring down the 1. It's going to be a negative 4, negative 11, positive 44. It's a positive 2. Awesome. We're all set. Okay, so to write our quotient then, we take the degree of my original dividend, which was second degree. Our quotient will be 1 degree less. So since it's a second degree, my original dividend was a second degree, my quotient is going to be a first degree. So this is just going to be an x minus 11 plus 46 over x plus 4, which was my original divisor. And, Ken, in standard form, decreasing order of power, first power, 0 power, and all my coefficients need to be integers, no fractions, which is what I've got. That leading coefficient is a 1, that guy is a negative 11, which are integers, so we're good. Guys, head on over to the next page of notes. I have another one for you, multiplying and dividing, so I'll meet you over there.